Alright, today we are going to start trigonometry, and you may remember some of this from geometry, but this is our famous mathematical princess. Maybe your geometry teacher told you about her, but it's Princess SOHCAHTOA. And this is just a way to try to remember sine, cosine, and tangent. So, sine is the opposite over the hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Alright, now just to remember where these come from, let's take a look at a right triangle. Alright, in order to do these, we need to know an angle, and we are going to call the missing angle theta, just a Greek letter theta. The opposite side is always opposite from the angle we're looking at, and adjacent is the side that's touching it. It's adjacent. And then hypotenuse is always the side that is across from the right angle. Alright, so hopefully that's something that you do remember from geometry. We are going to add on to this, and we've got something called cosecant, secant, and cotangent. And these are actually just the reciprocals of sine, cosine, and tangent. So, 1 over sine, since sine is opposite over hypotenuse, that's just going to make cosecant hypotenuse over opposite. Secant is the reciprocal of cosine, so this would be the hypotenuse over the adjacent. And cotangent is just the reciprocal of tangent. So since tangent is opposite over adjacent, cotangent is the adjacent over the opposite. Now, a way that I try to remember, usually cotangent is easy to remember that it goes with tangent. Cotangent, tangent. If you notice here, cosine starts with a C, secant starts with an S. So those two are the ones that always pair up. Sine starts with an S, cosecant starts with a C, and these are the two that always pair up with each other. Alright, let's go on and try a problem. Alright, our first example, you will see theta. The angle we're looking for is right here. Remember, hypotenuse is always the side that is across from the right angle. Opposite is the side that is not touching our angle, so then we do not know what the adjacent side is. We are going to use Pythagorean theorem to find our missing side. So just a squared plus b squared is equal to c squared. If you do this work, you will see that you end up getting x squared equals 144. X will be 12. So our missing side, the adjacent side here, is 12. Sine is opposite over hypotenuse, and if you want to do this, you can remember it's SOHCAHTOA. Sine is opposite over hypotenuse, so opposite side is 5, and the hypotenuse is 13. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. And then all we're going to do is flip these fractions to find cosecant. Remember, sine starts with an S, cosecant starts with a C. The cosecant of theta is 13/5. Secant, and again CS, is 13 over 12. And cotangent is just reciprocal of tangent, and that is 12 over 5. You also want to make sure that you guys reduce these fractions. So these fractions right here were already in simplified form, but sometimes they won't be. So make sure that you reduce your fractions. Yay! Alright, maybe remember doing these. This is our HSL, HL, and again, this is 30, 60, 90, and 45, 45, 90 triangles. So 30, 60, 90 triangles just means that we have a 30-degree angle, a 60-degree angle, and a 90-degree angle. Our 30-degree angle is always smaller, and our 60-degree angle is always a little bit bigger. Of course, the 90 is the right angle. Now, if you had a teacher that taught HSL, H just stands for the hypotenuse, S stands for the short leg, and the short leg will always be across from the smaller angle, and L is the longer leg. It's across from the bigger angle. Now, this is just a way to remember how to do this. If you always want to go from something smaller to something bigger. So S is the smallest. To get to the hypotenuse, you're always just going to multiply by 2. So if you double your short side, you're going to get the hypotenuse. If you multiply your short leg by radical 3, you'll get to the long leg. And then at the bottom, you would just do the opposite. To go from something bigger to something smaller, you would divide. So to get from the hypotenuse to the short leg, you divide by 2. To get from the long leg to the short leg, you would divide by radical 3. And this, just so you don't think I'm making this up, comes from a equilateral triangle where all the angles are 60. If you chop this in half, you get a 30 and a 30-degree angle. Remember, equilateral triangles all have the same side, so if we just pick a 2, if I chop that 2 in half, I get 1 and 1. And then if you did Pythagorean theorem to find the missing side, you would find that this is 1 times radical 3. That's where these numbers come from. Alright, the other triangle that we're looking at is a 45, 45, 90. So, if I've got 2 angles that are the same, I have 2 sides that are the same. The little shortcut here is if you take the leg, and if you multiply by radical 2, you'll get to the hypotenuse. If you know the hypotenuse and you want to get to the leg, you would just divide by radical 2. And again, this is built from a square. So if you had a square where all 4 sides were the same, and you draw the diagonal, and you did Pythagorean theorem, if this side was 1, this side was 1, and you did the Pythagorean theorem, you would find that this side is, the hypotenuse is 1 radical 2. Alright, let's try some of these. Alright, if I want to use my HSL, you have these arrows going away from the S, and it always goes 2, 3. 2, and then radical 3. The bottom is just the opposite. Divide by 2, divide by radical 3. Alright, so you see here that we have 30 degrees, which makes this the 60. 8 is the hypotenuse, because it's across from the right angle. X is the long leg, because it's across from 60. And then we don't know what this short leg is. So I know the hypotenuse. If you look down here, to get from the hypotenuse to something else, we can only go to the short leg. I would have to divide by 2. 8 divided by 2 gives me 4. Now, to get from the short leg to the long leg, because that's what I'm really looking for, I need to multiply by radical 3. So to get x, x is just going to equal the short leg times radical 3. And then we're done. Now, another thing that you could do if you don't remember your rules for this, you could also do some SOHCAHTOA. So let me just show you that. So here's 30. Let me erase some of this other stuff here. Let's just clear this off. Alright, so if we start with 30 degrees, this is our hypotenuse, this is adjacent. What uses A and H? That would be cosine. Cosine of 30 is equal to my adjacent side over my hypotenuse. To get x by itself, I'd multiply both sides by 8. I've got 8 times the cosine of 30. If you use your calculator and type cosine of 30, you will see that it's radical 3 over 2 is equal to x. If you do this work here, 8 over 2 reduces to 4, and you're going to get the exact same thing, 4 radical 3. So, the 30, 60, 90 rules are just a shortcut to get it. Alright, let's take a look at the 45, 45, 90. Again, if this is 45 degrees, I know that this is also 45 degrees, which means that those two are the same. The rules for HSL, to get from the leg to the hypotenuse, you multiply by radical 2, or to get from the hypotenuse to the leg, you divide by radical 2. So, I know the hypotenuse here. to get to either one of those legs, I would divide by radical 2. So x is equal to 5 divided by radical 2. Remember, we can't have a radical in the denominator, so I would multiply the top and the bottom by radical 2 to get 5 radical 2 over 2. If you don't remember those rules and you want to do SOHCAHTOA. So I'm going to erase this stuff, and we're going to take a look at a SOHCAHTOA here. Here's the angle, theta. This is the opposite side. This is the hypotenuse. Sine uses opposite over hypotenuse. So sine 45 equals x over 5. Multiply both sides by 5. If you use your calculator to type sine 45, you'll see that sine of 45 is radical 2 over 2. Radical 2 over 2, and if I multiply that by 5, you'll get the exact same answer. 5 radical 2 over 2. So either way works. 45, 45, 90 is just a shortcut.